filed a patent and published it on novel intermediates useful for preparation of vaccine and processes. She has published more than 25 research articles in chemistry, environmental science, research technology, education technologies. She has presented papers in education technology at College of Engineering, Pune. She has published that content. She delivered a talk at Amrita University, Amritapuri. She has presented a paper at IIT Kharagpur, and she has organized 2 education technology workshops. One is at VNRVJIET, another one is at Cross College for Women, VHEL, Hyderabad. She has contributed a lot for the education technology, not only at VNRVJIET, but also at several engineering colleges in and around Hyderabad. She explored her content, especially on ICT for enhanced teaching and mindfully, learner-centric approach in higher education, classroom management, and so on. She has completed many massive open online courses, MOOCs, through IIT Bombay, MIT, and Arizona State University of USA. She had professional memberships in variety of the professional bodies. A few are like this: associate membership of International Congress of Chemistry and Environment. She is Board of Studies member, Environmental Studies, JNTU Hyderabad. She is also a Board of Studies member at Guru Nanak College of Engineering, and she is chairman, Board of Studies, VNRVJIET in chemistry. She has published 3 books and 3 lab manuals for JNTU Hyderabad and also JNTU Kakinada. Let us give a big round of applause and welcome her to deliver our talk today on this dais. Welcome, madam.
Thank you, sir. So a very long introduction has been given. So I was also trying to identify myself in that introduction. I came to know that it is about me, but still I was trying to identify all those things which were very nicely given by LC University of Sir. So all that apart, I am one among you. That is all in terms of professional way of introducing a person, but I am one among you like a normal human being. So today, actually, when Tirupati sir approached me to give a talk on human values and ethics, I was just thinking a lot, like how should I teach values to people? And teaching values to people is not so very easy because all of us have those values, but we have submerged it somewhere else. And that too, teaching values on a platform which was running throughout from 4 days and talking about the fabrication of nanomaterials, the advanced technology which is taking into the world with so much amount of applications around it. So nanotechnology, when I was just looking at it, and as a part of this workshop, when I was talking about or thinking about this particular topic of discussing it with you, that nanotechnology is talking about characterization, building up devices, structures, and some of the lectures I was listening to the lectures and almost high-end applications wherein materials have been designed where they are able to sense like a human being. So looking at this, I was just thinking like, how should I deliver a lecture related to human values? And I was just, even before coming into this auditorium also, I was just thinking, will I be able to do the justice for that schedule which is given to me, human values and ethics? So before I go into the designing aspect of my presentation over here, I have one small question to every one of us. The picture over here, it was put quite long back as soon as I entered, which is the part of my presentation, and I had my colleagues discussing a lot on this particular picture. Ma'am, there are stars, they are showing everything in life, and everybody were relating to all the things which are shown over here. Why I chose this picture is we start at a place and we end at a place, birth to death. And there's so many transformations which go on. So which part of that would you feel best? Is it childhood, where there is lot of experiences, where the brain is open to a number of experiences and you share those experiences, you cherish those memories and all that? Or is it adolescence, where our physical health, I should not say our, I think I'm quite old, so your physical health is at peaks and you can do anything, any task given you are able to fulfill? Or is it of my age, where I have come to a stage where I start preaching wisdom and I start guiding people? So I was having this question, which would you prefer to be the best? Is it the childhood or your adolescence or the late adulthood? Which one would be better? Childhood. Why? No work. Very good. We all prefer to be like that, happy without no work, no stress, nothing. Nobody is there to stop you. But ask the child, the present day child, you ask that child, she or he also will have a number of things to talk about. So every stage in life is a unique stage here, whether it is childhood or adulthood or adolescence. Each one has its own importance. And all these three stages, if you are able to synergize and if you are able to take ahead, be helpful at every stage of this life, where help the children to experience the things, guard them, because you have to safeguard them. The child doesn't know everything, right? You have to safeguard. In adolescence, there's so many things to which you are exposed to and so much amount of stress. So let the people of wisdom guide you in a proper way, telling you things in a very patient manner. And at the same time, the people who are into late adulthood, they should be respected here. Today we have lost that respect, because I don't know where we have lost it. Even I and others are also experiencing this. We know what respect is, but we are not putting it into actions. So all the three stages, they go hand in hand, helping one another. And that is what I wanted to show you over here. And this is what, like at every stage, the development, what is taking place, birth to death, and again rebirth, or again you have another new life coming into the being. So this is a continuous process, and this is what we are talking about from a which scale to which scale in terms of your nanotechnology, because you are talking everything, manipulating matter at the atomic scale. So from macro to atomic. So I went from micro to macro, reversing it in terms of our life. And I always love to quote this, the famous person behind nanotechnology, the father of nanotechnology, Richard Feynman, who says there's plenty of room at the bottom. So keeping this in mind, I went back to design my title of today's presentation, where I say it is this is what is happening with technology. Yeah. So that's the reason why, instead of putting it as human values and professionalism and so many other titles which are coming, I thought I'll coin up my title to abundance. Because as Richard Feynman said, there's plenty of room at the bottom. Let's start building up this abundance in ourselves so that it really becomes the secret of giving, right? So I'll just move towards this side so that you can watch the slides on both sides. So I just wanted to quote a few quotes of Richard Feynman, where Richard Feynman is not only just a physicist, he's a professor of physics who has been awarded Nobel Prize. He's a great human being and who has mastered not only physics, but also mastered thinking, and also has preached a lot of humanism to people. And one of the quote which says that if you want to master something, you have to teach it. So not only just physics, he was also teaching about how you can take things
in an easier manner and take it ahead. So I would just share a few quotes of Richard Feynman before going into the actual design of this lecture. There's another one which says, what I cannot create, I do not understand. So do it with your own hands here. Then you will have the confidence of speaking about it and projecting yourself very confidently to the world. I'm just sharing few quotes. And these two quotes, what they say is, doing mistakes is not wrong. We learn a lot from our mistakes. So mistakes would definitely be a learning. And also knowing the name of something is not enough. You have to know the complete detail, in-depth knowledge about that something. Only then it becomes useful. Just naming it is not enough. So I would recommend all of you to read this particular book, that is Surely You're Joking, which is by Richard Feynman himself. And as I've told you, he's a person of curiosity. So I thought I'll connect with you being over here because. So this particular book, Surely You're Joking, which is by Richard Feynman, and he's, as I told you, a great human being. And he always reminds us about all these 4 points which I'm projecting over here. Always ask, be curious, because he was very curious, and he's a person right at the age of 12 years itself. He had his own lab, a small lab, where that lab consisted of a heater, and he used to fry French fries and eat it in the night when he was hungry. And then he had a small battery, and he also had a lamp bank. And apart from that, he has designed in such a way that he had headphones in his ears, and he used to listen to music, and he kept an alarm to that. So whenever the parents came inside, what he was doing, that alarm is to go up. And that's how he could realize that, yes, my parents are monitoring. So he was really very curious, and that's why I'm asking you to read this book, which shares a lot of interesting stories about the person and his experiences. And the main points outlined in this particular book and the key takeaways also I'll be discussing. But what he suggests is always question. If you don't have that questioning, then there is no answer for all the doubts what we get. It is not in the class I'm talking about, even in life also. So continuous questioning and enjoy the joy of learning and acquiring new skills, because the national education policy also is talking about skill-based education, and approach life in such a way that you have an open mind. If we don't have an open mind, then the approach towards life will be totally changed. And apart from that, have an inclination to be adventurous. So always try to be adventurous and try to explore. And the key takeaways of this particular book is all these, which he speaks about as a part of the book. That is, get curious about the world. I was telling you, be curious. Try to know whatever comes in your way. Don't just accept it just because it has been there since long. And then the second thing what it says, we are always bothered about this particular one. It's not your responsibility. We always try to live up to somebody else's expectations, losing our own zeal of life. It is nice to live up to somebody's expectations, but life completely should not revolve on the basis of somebody else. If somebody is telling you, okay, I'll do this. If somebody is telling you, do this, I do this. There are so many things which are coming now, and with technology, you have number of opportunities. But how well you can do it, and to what extent you can do it, that is your own responsibility. So see to it that you grow up to yourself, not up to somebody else's expectations always, and make your life stressful. And then the cycle of life. We know all this. There'll be joy, there'll be sorrow, there'll be failures, there will be victories. Everything will be there. But the end is again where we start once again getting up, rebounding back and regenerating back. That is the cycle of life. Let's rebound and regenerate and go ahead in life. That is another key takeaway. That's the reason why I'm asking you to read this book. and you will really find a lot of interesting stories. And this had led me to talk about this term abundance. And the acronym for abundance, I'm leaving it open for you. You can look at what each letter means to you. Abundance over here, which I said the gift of giving in my first slide where I was finding the title of this talk. If you look at this abundance over here, ask and you shall receive. Without asking, nothing comes to your doorstep. We are not something really very great where everything, by the time we just close our eyes and open our eyes, it is right in front of us. And I do remember, but I still have a doubt about this. I would like all of you to clear my doubt also. I was brought up telling that, saying that Adagande Ammaina Pettadu ani. I have a doubt related to this because always the moms are at the back of us, no? They'll be always asking, you want this, you want this, you want this, you want this. I don't know how this saying has come. Anyway, we'll discuss about it afterwards. But in life and in the world, if you don't ask, you will not get it. So you have to ask and you have to communicate with people. The next one which says, be the change. Everywhere we require change. Every time, everybody is talking about change, which is, of course, not very, flexible, or sometimes it really puts you under pressure. So be the change so that you become an example to a number of people around you. Next thing is universe is your source. That's the reason why I thought I put up that picture over there. Open hands if you are able to explore everything. That's why they say if we don't want a half-filled glass or a full-filled glass, an empty glass is able to accommodate a number of things into it. So let us keep our mind empty to get involved. When I say keep it empty, okay, ma'am, we'll forget about what all you have taught in the class. Don't say like that, right? That emptiness over here is giving space into our brain. And yesterday, in one of the lectures, we were looking into how neural networks is speaking about the signals of your brain and trying to give the senses even to robots. And another one is notice your thinking. What you're thinking about. What are you going ahead with your thought process? That has to be taken care of. Decide you are worthy. You don't require somebody else to tell you that, yes, you are great. You know you are worthy. If you are into this world, you are worthy and you are ought to do something in this world. Next one is attitude of gratitude. Anyway, I'll be talking about this a little more as I proceed through my slides. Having gratitude, thankfulness towards the people in our life is very much required. Apart from that, no fear. Fear in the sense, not to fear from things which we are doing. But it doesn't mean that, yes, I don't have fear, so I will not respect any one of you, whoever is there in front of me. So there are meanings for this. Please take the meanings in a positive way. And be compassionate. Apart from that, everyone is eligible for what they want in their life. Nobody is going to ruin your life. It is there in our own hands how we take our life ahead. So my whole presentation is around this abundance, where I have also quoted the meaning of abundance. Abundance is to see that there are endless opportunities around us. There's so many opportunities around us, but we don't identify them. We only think that, okay, let it come. I will look when it comes to my doorstep. And they are very close to you. It is not far away where, okay, let me go today. I'll take some long drive and then only I'll get some chances of fulfilling my wishes. Nothing of that sort. The abundance is there right next to you, available next to you, and how you identify it and how you show your gratitude towards the abundance which is available to you. And we have already realized, I think, that abundance when we face the pandemic situation, right? What all the things which were there with us and how much we were deprived of some things and how we wanted them back. So you can relate your abundance to the pandemic situation which we have crossed over and we have come so far in our journey in spite of losing our loved ones. So my whole presentation is around this, the challenges for this abundance, the opportunities and the transformations which we have to take to reach to this abundance, which is the gift of giving. So coming over to the challenges, next. We have been seeing this. There's so much of transformation in our education systems. Today, why I'm talking about only education is because we are sharing this platform of education, we being teachers and students being the participants over here, and also some teachers and research scholars. So that's why I thought I'll talk about the challenges in the education system. Education nowadays has become so easy. Like you are being experiencing the same thing. You're sitting over here and you're hearing to so many eminent persons who have done a great amount of research in nanotechnology. And you could also go through their work, their research, and what all wonders they have done in nanotechnology by just sitting in this particular room and getting connected to the people around the globe. So that's why no more four walls of education. Everything can be explored, and you also can become the guide for us. It's not that only the teacher is always showing. That's why I showed you in the starting the three stages of life: the childhood, the adolescence, and the late adulthood. All three have to go hand in hand, respecting one another and sharing with one another. Only then the world will be happy. So for that reason, if you are looking at this particular one, even with one click of a button, you are able to get all the information to your wherever the screen or on whichever you're monitoring. But how authentic that information is and what has to be taken care of, that is being guided by your teachers. So please respect your teachers in terms of the information which is shared and educating you to face this world with utmost confidence. And as I was talking about the national education policy, one of the part in the higher education is towards a holistic development. We want vibrant students who will come forward and who will be creating wonders related to this world. Wonders over here doesn't mean only technology or something which is creating comfort or anything. A little amount of humanism, right? That is very much required in all these wonders. How you are transferring your knowledge to a student through the length and the breadth. It is not only just about the domain what we are teaching, but this all-round and holistic development which has to be taken into consideration. So when we look at the national education policy, one of the things which speaks in your national education policy related to higher education is towards a holistic development. And that's the reason why I think Irwin sir has incorporated this human values into this technology of nano, right? Hope I am not putting all of you to sleep after lunch. And when we are talking about this national education policy also, the 4 C's always, everybody will be talking about 4 C's, 4 L's, 4, there's so many things which are coming out. And everybody is telling it is the 21st century skills. It is not just the 21st century. Every century should be looking into these skills. What are they? Communication, collaboration, critical thinking, and creativity. Everywhere, wherever you go, everybody is speaking about this. Communication, collaboration, and then critical thinking and creativity. When does this happen? How does this happen? I know about the 4 C's, but what? Maybe I know about the first C, communication, which I'm doing now right in front of you. Collaboration, maybe I've collaborated with my faculty members in taking my curriculum ahead. And talking about critical thinking and creativity. How do I address this? And how do I make youngsters like you think about all this critical thinking and creativity and all this? And how do I drive you towards that? That is what is the challenge which is there when I'm talking about this abundance in our life. So here what when I said, how do I address those challenges? Then the first thing which has come into my mind is that circle over there. Whatever we are learning, whatever, it revolves in this particular circle. What it says over here is, what is there to learn? And why I am supposed to learn? And how will I learn? Apart from this, I also have another question. When will I learn? Not in when. Is it in my school or is it in my college or is it my journey presently with you? So there are so many things which come to our mind. What I am supposed to learn, why I am supposed to learn, how I am supposed to learn, and when I am supposed to learn. Because time, we don't find much time for all these. And then for that, mindfully, I have one word to say. And all of us love this word, raining. The minute it rains, even if we are not going out and getting ourselves drenched, We look at the rain and we enjoy. So if you look at that rain over there, what R stands for and what A stands for and what I and N stands for. R stands for recognize. Start recognizing the things around you. Look around rather than looking at only one single device which is able to connect us throughout the world. Right? I find somebody over there, even now also, busy with the mobile phone. Maybe, are you recording? Are you recording? Then, even now you're busy with the device, and this is from last 15 minutes with headphones in your ears. That is the respect what you're paying to your elders who are standing in front of you. Anyway, let's go ahead. So when I'm talking about this rain over here, recognize the things around you. And A stands for allow the experiences to come to you. Don't just listen to people. You also experience. And presently, I find that in the generation now. They are not going to listen to the wisdom what is preached. They want to experience it. They want to observe what is happening. And only then they want to learn from that. So allow yourself to be experienced. And I stands for investigate, go around, which is what I've been aiming towards your curiosity, which has to be built up to a greater extent. And finally, natural awareness, which I was talking about. Look around and be always aware about what are the things which are happening. Not only the ones which are interesting you, but other than that also look at the things which are there around you. Every other thing will teach you something new in life. Even if you're sitting for 1 hour in an auditorium, one point might trigger in your mind, which will change your life. So that's the reason why it's not that 1 hour I have sat, full 1 hour knowledge I am supposed to get, and I am supposed to remember, and I should become something really very great, where I can jump from this planet to another planet. It's not like that. So rain is very much required for us. Recognize, attempt to experience, investigate, and have the natural awareness related to the things around us. And this is one of the books which I was reading, and I also ask you to go through it or read it. And anyway, I'll be summarizing this Eat the Frog. I am not a brand ambassador for the Chinese or Japanese asking you to eat the frog, right? So this is a book by Brain Tracy, which speaks about 21 ways of how you can avoid procrastination. Because all of us, any time in our life, we might have told, I don't have time. Somebody asks you something and you say, I don't have time. I'm very busy. Everyone is having that 24/7. But still, some people are able to use it in a very productive way, very happy way, and very stressless way. Right? So this book really tells you what that procrastination, how you can overcome that procrastination. It is a nice small book which my colleague shared it with me, and I am sharing it with you. Right? And all the summary of this particular book, what it tells about, I have just put down some points. I will share those points and I will just enlighten you those points. So all the things which are shared as a part of this book are outlined under these particular points. Set the table. Very good. I think this first point says, just now we had lunch, ma'am. What are you talking about? Set the table. Are we supposed to arrange all the dishes and everything on it, or are we supposed to go to the canteen and sit at a table which is all set for us to give some nice snacks or anything? So set the table is have the clarity of what you want to do. That is the first thing which has to be taken care of. So you have to have a clarity what you want to do and how you want to do and with what inputs you are supposed to do it. So set the table is the first one. Next, all of us do the second one, but I don't know whether the plan really executes or not. But it is a nice way of doing it because one day it will definitely execute. This is what we have learned right from our childhood. Start working, work hard. One day you will win. So plan every day. But look at your plan at the end of the day. Did you finish some of the tasks which are there in that particular plan? And if you regret that you didn't finish some of the tasks, maybe you could send them to the next day and then go ahead with that. So planning is not bad. You can plan it, but the execution also is supposed to be taken care of. And the next one, what we are talking about is 80-20 rule. 80-20 rule, what it says is 20% of what targets are given to you. If you are able to do it effectively, 80% you will achieve. Identifying that 20% among your tasks is very, very important. So finish off that 20%, 80% will be at least. That again depends upon how we are going to go ahead with that 80-20 rule. And the next one, what is practice creative procrastination. All of us claim that we are multitaskers. We are doing multitasking. And that's why we are not in the line. We say that we just go into the loop line. So practice creative procrastination in the sense over which are the important ones, put them first and then come back to the others. Once you put your important ones and you finish the target, you will not be stressful. You'll be able to do the other things very easily. And the next one is prepare thoroughly before you begin. Anything without any preparation would not work out very well, right? So preparation is very, very important for anything, even in our life. The next thing is apply the law of three, which is similar to that of 80-20% rule. Pick up the three key, important ones. Do it. The rest of the one will fall in line. So they're almost similar to that 80-20% rule. And the next one is focus on the key results. Doing something without talking anything about the results or without coming down with the results is not at all good. Think about the result. Think about the end. And that's why one of the habits in 7 habits is begin with the end in mind. And when you begin with the end in mind, you put first things first. So all of them line up like that. Next one is upgrade your key skills. Already I have been speaking about these key skills in terms of the national education policy also. Identify the key constraints. When you're doing a task, which ones will put you back, which will not allow you to go further. If you're able to identify, you will address them first, and then the road becomes like outer ring road, not like our Pragati Nagar road with so many dumps and bumps where we have to stop every second and go ahead. The next one is put the pressure on yourself. Nowadays, all of us, anything which comes to us, we say, oh my God, I'm stressed. The word looks very fancy. Everyone, I'm stressed. I'm stressed. Why are we stressed? Is that stress being given by somebody else? We always say, somebody gave me that stress, not me. Somebody told me to do this, not me. Then why are we giving that chance for them to put us on to stress? So see that you plan up your things, and for that, when I said put the pressure on yourself, that means try to work hard, put all the things in terms of put the first things first, work on them, and definitely it will be a win-win situation for you and as well as the person who has given you that task. So putting pressure on ourselves is not putting stress on ourselves, but planning, which comes in the second point over there, planning every day so that that pressure can be lessened. The last one is motivate yourself into action. Always don't expect somebody else will come and tell, come on, go ahead, do this, do that. First, motivate yourself. I am something great. I have all my organs are functioning. I have the energy to go ahead. I have things or I have the comforts to take care of. When you are able to see all the things, the positive things around you, you are motivated to do the task. But always, the minute we get up in the morning, one thing which comes, oh my God, another long day. Finish. There itself the energy levels. The battery has come to charging again. Oh my God, such a lovely day. And you love to watch yourself. I have seen the youngsters because I have my son. The minute he gets up, next to his bed, there is a mobile phone. He doesn't require a mirror or anything. He takes the mobile phone, he looks at himself, he nicely does his hair, and then he comes out. Right? So you're looking at yourself. Look at the beauty what God has created. All your organs, everything is functioning. And you are yourself so great where you're looking at the people usually they say, when you get up in the morning, look at something which is a good omen or whatever. We are all looking at ourselves itself. So if the day is bad, you have to blame yourself only, not somebody else who's coming into your room. And your mom doesn't come to your room because already you might have told her, you're not my lucky charm. Indirectly, don't come and wake me up in the morning because you want to get up. And you are looking, all of us are lucky charms for ourselves because we are looking at ourselves in the mobile phone, which is the mirror for us. So I'm asking, I was sharing this with CSE students, buy a nice mirror. It doesn't charge much, 4,000 or 5,000. The mirror should be good here. Put a nice mirror in your bedroom, stand in front of it and hug yourself. And say, see, I am alive today. I am so happy today. Hugging yourself is the motivation what you give for yourself. Because we don't know. We have a lot of hope in our life saying that, yes, today if I'm not done, tomorrow I'll do. But in the world, there are so many lives which are coming to end after that night. We don't know about all this. Only when we get up in the morning, sometimes we lose our loved ones. And we just say, yesterday night itself, I spoke to him. Yesterday night itself, we were having dinner and all that. So, but still we get up with that hope saying that, yes, tomorrow I'll do it. Then when you have got up in the morning, love yourself, motivate yourself. And that's what I wanted you people to realize. And this was also shared by one of our colleagues in VNRVJIET, where if you are changing your mindset, you can play a carom board even on the ground without having all the facilities with you. Kiran sir, thank you for sharing this in design thinking, right? So this is one thing which really I was just looking at it and we always ask our parents, I want this, get this, get this, get this. But look at them here, they don't have anything. And they have made a nice carom board and all of them are playing over there. That's wonderful. And that is what is the one which is required by all of us. Because education has changed us in such a way saying that, oh, I will not do this, I will not do this. Oh, it's so cheap. Should I play on the ground? Should I sit on the mud? Should I sit on the ground? All this, a mindset has changed. But see the enjoyment over there, see the innovation which comes out even out of poverty. And I'm coming to the transformation. I've spoken about the challenges. I spoke about some of the opportunities which you can go ahead because we ourselves have to tune ourselves in order to have that abundance in our life. Everything is there in our hand. We have to look into ourselves and we are the ones who can create something, who can destroy something. So don't expect somebody is putting you to that particular stage. We are the ones, we are responsible for everything in our life. And therefore, what is the amount of transformation which is required for us to go ahead? That is what I'm going to discuss as the last part of this presentation. I didn't finish yet. Thanks for your claps. Thank you very much for the clap. That means you have woken up just now. Right? So this also I've been sharing with number of engineers. The transformation is changing our perspective of engineering. This is also not mine. I happened to listen to some lecture and I've picked up these points from there and I have been sharing it throughout my speeches. So engineering is looked up in a different perspective, where each letter has a particular significance, eagerness to learn, learning new things, always communicating, being nimble in personality, never tired of knowing something, and giving your best to the society. I'm not reading from the slide, please. You can look at it and you can understand what are all the points which are there. So engineering is defined. Always, when the first question when you have come to the classes, people might have asked, what is engineering? So now you can change the perspective of engineering and you can talk about all this. Engineer in action, they say. So what is that action? Always be ready to learn, unlearn, and relearn. Then life will be really wonderful. If you think that you are something great and you don't want to learn, then there is a full stop which has come to us. So maybe I can talk about a little punctuation marks, ma'am. English ma'am is also over here. So full stop and comma and colon and all that. Let's not have all those in our life. Let us have open-ended sentences provided with ma'am permits that there should be some grammatical things which have to be taken care of. Right? So let's not put a full stop to our life and let's be exploring. And this is what is your engineering. Always learn, unlearn, and relearn. Thank you very much here. This clap is for defining an engineer, or you want me to stop? I will not stop even if you say. A teacher, if a mic is given to a teacher, she will never ever stop. And that is what is also understood by this famous physicist who says, how we are going to delegate your topic. Just giving a topic and talking about a topic is not enough. Of course, this is a pressure on us as well as you also. Don't ma'am, don't go back to your classes and tell, ma'am, yesterday she said, this is all what has to be done. So the teacher should come prepared in this particular manner. This is both for the teachers as well as for the students. Whichever topic you are teaching, what is the connectivity? Come down to the level of the people whom you are teaching. I might be a professor, I might be a scientist, I might be a researcher. But if I can't convey the message to my class, then I am a zero. So you are supposed to see in such a way that you are able to, and even if you are explaining it to your friend, explain it in such a way that your friend is able to understand. And you very well know the pain points. When you're understanding a topic, you had some pain points. Maybe you can overcome those pain points and explain it very clearly to your friend. So this is the way of talking about. That's why it says there is plenty of room at the bottom. Identify the topic, tell it in an understandable manner. Wherever there are gaps, fill up the gaps. Still, if that point is not clarity and you want some more examples, go back, browse some examples, come back. So it is not just the responsibility of the teacher coming to your class. When the teacher teaches a topic, it's your responsibility also to come out with examples and get back those examples to the class. That's how the synergy between the teacher and the student will build up, which is also another habit among the 7 habits, right? So be proactive, begin with the end in mind, put first things first, think win-win, synergize. And to do all this, there is one other habit in between think win-win and synergize, that is seek first to understand and then being understood. And for all this, we have to sharpen our minds. That's why the last habit says sharpen the saw. And I believe in this, where the S mantra, the C mantra is gone now. Collaboration, communication, critical thinking, and creativity. Now we'll go ahead. I said we have to transform ourselves. So let's move on to the S mantra. What it says, have the sankalpam, have the vision of doing it, right? And then talk about what is the commitment, what you have in doing that particular task. And then the hard work, what you are supposed to put in to get that task completed so that it is identified by others. And lastly, have the patience, which is not there with us. We very easily lose our patience. I said us, I didn't say you. If I say you, you'll start blaming me, right? So these are the 4 mantras which will really create or which will bring about happiness. Once happiness is there, success will definitely follow. So that is what is the 4S mantra. And for the personal transformation, because we are in the line of transformation, the steps which have to be taken into consideration for your personal transformation is record the outcome. When you're doing any particular task, think about the outcome also. That is what we say. When we are speaking to somebody else also, think about the outcome. Maybe in that hastiness we have spoken very harshly or whatever it is. But we can't take back the words. At least a word of sorry would heal the gap between the people. Right? So record the outcome for your transformation and then take the baby steps. Everybody they want you to change, they'll ask you to change very fast. It is not so very easy. You have to start again like a baby and then grow up into an adult. So take the baby steps for transformation and best where I said collaboration, the 21st century skills which we were talking about. Collaboration, learn from others, start collaborating, look at others, look around, and you'll be able to learn number of things from others. Be the outcome, see that people follow you, because always we say leaders are wonderful. And we say that leaders are born. I always contradict this. Leaders are not born, leaders are made. And leaders are within us. So let's lead the society so that we become a very good outcome. And another one is when the change is happening, definitely there'll be a lot of speed breakers. So you should be able to accept all those speed breakers and go ahead. Are we not causing the speed breakers on the road? Are we stopping off over there? No, the road has to become flat. Only then I will drive. Are we doing that? Are we doing that? Of course, we searched, is the speed breaker right from this end to that end? I find people going to the corner where the speed breaker doesn't end and they are able to take their travel through that. Always it is not possible. Once in a while, you have to go on the speed breaker also. So think about that particular one also and be your own cheerleader. I already told you, motivate yourself. apart from all those, these things are very, very important. Gratitude, kindness, and appreciation. These we have forgotten long back. We are not considering these. We consider only the technical terms and talking about going for advanced technology and all that. This advanced technology, which is there within us, has to be redigged once again. And when we are undergoing this transformation, the things which we are not supposed to look at, we get attached to a number of things and we don't want to move from there. Then the change will not happen. And sometimes we get entangled with a lot of emotions. So we don't want to come out of it. That also should not be there. No jealousy, no greed, no procrastination, no arrogance. If you are able to leave all of these, no anger, then definitely we will transform into what people talk about, saying that human values, professional ethics, and all these. So small, small things which are there in our life have to be avoided. Only then you can reach the world of abundance with gratitude, kindness, and appreciation. So that makes your life stress-free. And this is what is a mindful snack. Stop, notice, absorb, communicate, or be curious. And kindness, that is what I was talking about. Be kind to people. Kindness will help us in a number of ways. If you think we are something big, then that day is the full stop of it. Always try to be small. Small, not telling that, okay, I'll not eat anything, I'll not grow up in terms of my height or anything. Being on the ground, being very humble, that is what is required. And that takes you to greater heights. And that is what the last word in that kindness, I put down in another slide talking about kindness. So what that kindness, the acronym, keep in mind never to ignore the deprived people, neglected people. Each time serve them selflessly, which we have done during the pandemic situation. We addressed a number of things. And even now today, we have the NSS team in our college who is looking after about the fistful of rice. That kindness with what you're donating the rice is really going to become a feeding point for the people who are really suffering from hunger. And we all know the value of hunger, don't we? Don't we? So that fistful of rice, that kindness is very much required, which we are doing it. But extend that kindness to other deeds also. And when you are kind, you have all these. They might be only 10 reasons, but there are many number of reasons where relationships build up. Sadness goes away. The perspective of life changes. All this will happen if that word of kindness and that deed of kindness is there with us. And the next one, which I was talking about when I told you gratitude, kindness, and appreciation. Gratitude becomes a bridge for abundance. You are showing the gratitude. And here, 2 minutes, I'll share a story. I had a video in our group. I think everybody has watched, the faculty have watched. And there, a small story is shared. There's a 73-year-old person who goes to the hospital out of breathlessness. And the doctor says, you can't breathe properly, so we'll put you on ventilator. But it will cost very high. Then the old man started crying. Then the doctor said, oh, please don't cry. Maybe you are thinking about the money, what you're supposed to pay for the ventilator. So don't worry, we will see to it. The doctor was very generous enough. And he said, we'll see to it, don't worry. Then the old man said, I'm not crying for the paying the fees for the ventilator. I'm only crying that all these years, I never paid a money to breathe. God has given me that oxygen. I am breathing without noticing what I am breathing, or is it available freely, or am I paying for it? But today, I pay for my breath so many rupees, and I've never thanked God for giving me the chance of breathing this fresh air and making me live for that 73 years. So that is the gratitude, and that is the thanks what we have to say in our life. Have we ever told thanks to our parents? We say that, oh no, we need not tell thanks to our parents because they are there. Today they are there next to you. They are providing you all the comforts. They're giving you all the things which are required so that you excel in your life. But one time did we go back and tell them thank you? And when I tell you that thank you, ma'am, it becomes very formal. No, it never becomes formal. Once in a while, the thank you need not be in terms of word. One hug to your parents. One hug to your loved ones who has really created a change in your life, that is very, very important. Thanking your teachers also is very, very important because they are the ones who are guiding you, showing you the path in your life. So that gratitude has to be there definitely, and that will automatically lead to the abundance. Are we thankful to what all we are getting? Today we are able to eat 3 meals. Think about the people who can't even eat. And today the news says the wind is blowing so heavily that it will be very, very cold. You are able to sleep in your room with the heaters on or with the rug on. Think about the people sleeping on the road who don't have anything. And I'm not telling you to go back, rush back home, pick up the rug which you are sharing and give it to them. I'm asking you to pay that gratitude. You are having a comfortable life. So extend your comfort to the people around you. How much ever you can do it. And this is what I wanted as teachers and as students also. As teachers and as students, you have to expertise with the topic, whatever is being taken. You have to relate that topic to the real world situation. Only then the interest, because knowledge, whatever is coming to you, it doesn't happen with rote learning. You have to identify, you have to know the length and breadth and the depth of whatever you're learning. So that's why relate it, apply your knowledge, don't just leave it. Without application, there's nothing. So that's the theme behind this Richard Feynman. Always he was curious. He wanted to learn, he wanted to explore, he wanted to experiment. That's why I'm recommending you to read that particular book, which will motivate you towards all these things. And then reflect in terms of praxis, what action you have looked into, reflect it in terms of your outcome. And finally, collaborate, do it as a teamwork, pick up your choices so that your life becomes fruitful. And that is what will make a number of turns in your life and give you a very good and peaceful and stressless life. So this is what, when I told you, learn, unlearn, and relearn. Don't be like whales in the water, which don't come out for a greater period of time. They take long to come out of that water. Deep inside water they go. But a dolphin, every time it will come in, it will go up. It will come in, it will go up. So this is what is required. Come out, look at the world. What are the changes which are taking place? And go ahead in life. Then only that line which I was speaking about, learn, unlearn, and relearn will work out and really will make us great. And all your examination papers and all your teachers might be talking about Bloom's taxonomy, which will tell you the levels of teaching as well as assessment. And we say that it is lower order thinking skills and higher order thinking skills. But fortunately or unfortunately, the name Bloom, Benjamin Bloom was the person who coined that. Remember, understand, apply, analyze, evaluate, and create. But that Bloom also has another meaning over here, which creates value in our life, right? We are happy for the breathing which is happening with us. L, the love, the connectivity, what we have with people. And then talking about the other other letters in it. Observe your thoughts, which I have spoken a lot about. Gratitude, offer thanks, and then exercise. Exercise in the sense keeping yourself fit enough, sharpen your saw, be enthusiastic, because that keeps us moving always. And that's the harmony of life here. If you are able to transform with all these opportunities and the challenges as a part of abundance, and you're able to transform, inculcating any one of this in your life, then the harmony of life is really wonderful. And I would just give a quote: try not become a man of success, but become a man of value. Don't think I am talking only about man, become a woman of value also, right? So no gender bias over here. I found that quote, so that's why I just shared that quote. Next one, please. And this is what I got just before I was coming into this hall here. Maybe some of you might not read Telugu. I'll just translate it. I'll try to translate it to the best of what is given over there. So there's a fisherman who's going and picking up fishes, and a fish is caught in the net. So that fish curses this fellow. You are troubling me by catching me in the net, and I'm really coming to an end of my life. So I'll see to it that you will also get caught up in the net. And definitely it has happened. We are all caught up in the internet. We forgot speaking with people. We forgot exchanging our things with people. Everything in terms of emojis and expressions. The main expressions which are there when machines are coming and trying to feel our senses. When our technology is advancing, where machines should identify our stimulus, our brain functionalities and everything, we are becoming machines here. We are caught in that net, that internet, and we are caught in that devices. I'm not saying don't use the devices, use it, but use it efficiently and in a very positive way. So this is what I just wanted to convey, and these are the few, I don't say these are the values, but these are the things which we come across every day in our life. I think this would definitely transform our lives, and even today I am learning a lot, and this is what all I have learned I have been sharing with you. And I'm grateful to my profession because I can speak to or I can communicate and collaborate and go ahead with so many people around me, my teachers, my colleagues, my students and everybody. And that's what is with what I want to thank you. There is enough for everyone. If you believe it, if you can see it, if you can act from it, it will show up for you. And that's what the plenty, that quote by Richard Feynman. Can you repeat the quote, please? There is plenty at the bottom. Please dig the bottom and come out with that plenty and make your life happy and successful. Thank you.
Thank you very much, madam, for your enlightening and motivational talk. Now the presentation is for open for discussion.
I don't think we have to discuss something on values.
Yeah, students.
What would you like to say? Any comments? Understand your feelings?
I'll come to you. Yeah, here. Say there's a microscopic.
Hello, ma'am. Hello, all. This is Avinash, and I'm from Data Science. Ma'am, I want to share about two things. And actually, I'm very free to tell that things in Telugu.
Sure.
If anyone
Go
wants.
ahead.
And the two things are one is gratitude, and another one is forest mantra. And ఆ ఫోరెస్ట్ మనం ఒకటి గమనించాను సహనం అది అందరిలో ఉంది కానీ బాయ్స్ లో ఎక్కువగా గర్ల్స్ ఎప్పుడు చూస్తారు వాళ్ళతో ఎప్పుడు మాట్లాడాలి ఎప్పుడు లైన్ వేయాలి మొత్తం దానిపైన ఉంటుంది అదేదో మనం చదివే దానిపైన అది ఎప్పుడు వస్తుంది దానిపైన సహనం పెట్టాలి అండ్ సహనం ఒక్కటే కాదు ప్రతిదీ మనలో ఉంది కానీ దేనిపైన అది ఎక్కడ అప్లై చేయాలనేది మనం తెలుసుకోవాలి అండ్ వన్ మోర్ థింగ్ ఇప్పుడే కాదు క్లాస్ పెట్టచ్చు గ్రాటిట్యూడ్ అందరం చాలా టైమ్స్ టెంపుల్స్కి వెళ్తాం దేవుని దర్శనం చేసుకుంటాం బయటకు వస్తాం అక్కడ కొంతమంది బిగ్గర్స్ అనుకున్నాను వాళ్ళు కూడా మనుషులే ఒక 10 మంది ఉంటే చిల్లర లేదని అంటాం వాళ్ళు అడిగేది మనం సహాయం చేయాలి కానీ చిల్లరగా వాళ్ళు అడగలేదు సహాయం చేయాలి ఆ సహాయం చేసేది కూడా 10 రూపాయలు ఉంటే ఒక్కొక్కరికి 1 రూపీ ఇస్తాం 1 రూపీ ఒక్కొక్కరికి ఏం సరిపోతుంది అది 10 రూపాయలు ఒక్కొక్కరికి ఇస్తే అట్లీస్ట్ ఒక బజ్జీయో ఇడ్లీయో కొనుక్కొని అది మనం చూడాలి అండ్ దట్ ద థింగ్ అంతే మ్యామ్ థ్యాంక్స్ అండ్ ఇంకోటి జడ్జ్మెంట్ అండ్ మేడం ఇందాక అన్నారు నోయింగ్ అబౌట్ సంథింగ్ అంటే వాళ్ళ నేమ్ వాళ్ళ అవుట్ఫిట్ వాళ్ళు ఎలా ఉంటారో తెలుసుకోవడం కాదు వాళ్ళు ఏం చేస్తారు వాళ్ళ ఇన్నర్ ఫీలింగ్ ఏంటి వాళ్ళతో అసలు ఎలాంటి వాళ్ళతో మాట్లాడి వాళ్ళతో తెలుసుకొని జడ్జ్ చేయాలి వాళ్ళని చూసి సో ఇలాంటి వాళ్ళని జడ్జ్ చేయడం కరెక్ట్ కాదు అండ్ దిస్ ఇస్ థ్యాంక్ యూ థ్యాంక్స్
Wonderful, yeah. And I can see my outcome of my talk over there. He said that all of them are there within us. We are coming out with it. So please dig all your values which are submerged inside and come out with that. Wonderful. Anybody else? That's it. So nice, yeah. Nice session with our questions.
Thank you very much, madam, for your enlightening talk on human values and professional ethics. Madam, speaker is waiting.
Thank you, madam. Thank you for a wonderful session. And I learned from you how to celebrate the life, whatever, either it is professional, personal, or knowledge, or anything. Thank you so much for inviting us.
Thank you very much, madam. Dr. Josna, madam, Professor of Chemistry. She has enlightened our students about the three stages of life. She recalled the quotation of Richard Feynman, and she has explored the abundance in nature in terms of challenges, opportunities, transformation, and also she has emphasized some guidelines of National Education Policy 2020 for the holistic development of the students. She has suggested 4 C's mantra, RIDE mantra, and 4S mantra, snack mantra, and so on. And she suggested one more book, Eat That Frog. Really, madam, your talk is motivational for our students, and we promise you to practice human values and professional ethics in our life. Thank you very much, madam.
Thank you
Give her a big round of clap.
all for your patient hearing and clapping and motivating me in between.
Now, the last session of the day, that is the distinguished lecture, DL6 by Dr. R. Rakesh, Assistant Professor of Physics, NIT Warangal. He has completed his PhD from IISc Bangalore, and he is also a visiting professor for ISR Bhopal. His research area is nanotechnology, designing nanomaterials, especially 2D shaped nanomaterials, self-powered devices, and energy harvesting materials. Dr. Rakesh has published 55 research papers so far, especially in RSC advances, ACS applied energy nanomaterials. Dr. Rakesh has completed 2 DST projects worth of 70 lakh rupees, and he is guiding presently 6 research scholars for PhD. Now I welcome Dr. Rakesh sir to deliver his lecture. Thank you, sir.
Yeah, thank you very much for the introduction. Am I audible?
Yes, sir.
Yeah. Oh, thank you. Hope you can see my screen, right, everyone?
Yes, sir.
Yeah. So first, I would like to thank Dr. Josna, madam. I was a little worried before I'm going to give my lecture. Like it is mid in the afternoon. Like people will be very sleepy and all. But by God grace, Josna madam has given a very highly motivated lecture, and people got activated to the amount where they could not go to sleep again. Thank you, madam, for the motivational lecture.
Sir, ma'am is saying
Yeah, fine.
thanks to
No,
you.
I'm just looking at my slide. Yeah, fine. So I welcome all of you, all the participants in the IEEE Summer School on Nanotechnology. So we have been gone through many lectures for the last 4 days. So as today is the last session of mine. So in this session, I'm going to show you a very broad level of what are the different characterization methods which are available for the nanomaterials. So the characterization starts from macroscopic to atomic level. Like some characterizations can deal with at a surface level, some deals with the atomic level. I'm going to show you all those things one after the other. So before we start up my presentation, let me tell you why do we need to do a research. So you must be having, students must be having a question, especially the who are in undergraduate level or postgraduate level. They may be wondering what is meant by research, why people want to do research, why they want to get a degree and all. So whatever the research people do, so please keep it in mind. So we do research for the betterment of science initially, but our initial thing will be only that part. But later it will extend it to the other side. Like once the science gets betterment and you're going to see a betterment in the human life, then once your human being is betterment, then society gets better and the world gets better. So you may be doing a small research, but in a later part, maybe a later time, it become a big impact on the world to make a better world for all of us. So people who wants to do research or who wants to enter into the research field, please make sure so your research should fit one of these categories so that your research will have some value for the society. Okay. Now I'll take a simple example. So for the research part of it, if you look at here, there's a pandemic for the last 2 years. but many people spent sleepless nights to find a alternate solution for the pandemic, and we could find 2 vaccines and we could save lakhs of people across the globe. So that is the impact of research. So, okay. And similarly, we also, so students must be connected here. So we also found many online modes to teach or to learn things. Now we have almost all the platform. Even I'm giving them online lecture. So all these things, effects of research by someone who already did it for us. Like someone has faced the problem, he has taken the problem, he has done some research how to make online presentations, and he made many platforms for us to present the lectures now. And same with your payment system, your Google Pay or Paytm or Phone Pay, whatever it is. It was initiated by some problem faced by the society in the transaction of money. So someone has started the research how to make a safe payment, a gateway. So we nowadays everybody using right from food shop vendor to a 5-star hotel also. So everywhere you can have all the complex. If you see, the person has started the research to make a payment safer. But now if you look at here, because of that, the world has become better and better now. Everybody has enjoying that comfort, paying the bills from the fingertip. Okay, so that is the value of research. That is the impact of the research what we get if you do the research. So similarly, we have technology also drastically improved over the years with the transistor size reduction. This also because of the research. And come to the what are the basic human needs. So if you look at here, these are all required for our human needs. These are the things which are essential for a human being. If you look at the last part where I'm pointing the pointer, so these two are related to the research side. Everybody wants a better food, better water or clean water, healthy lifestyle, a secure environment. Okay, so all these things, some research is required. So if you want to have a clean drinking water, some research has to be done. So we are having a RO water filter in our house, that is good and well, but there are people who don't get a proper drinking water, proper healthcare facilities, or proper health, proper nutrition, or maybe employment. Okay, so all those places, people has to do some research to make it their life better and better. Of course, along with this human needs, we need Wi-Fi and battery also. Nowadays, our life is running around the Wi-Fi and battery. Everybody using mobile phone. Okay, so at this place also, people done a good research. Okay, and so a few years back, there was no good research. There was no good Wi-Fi facility or no good internet facility for us. Now, if you look at here, we have everybody is accessing 1.5 GB or 2 GB for a day nowadays. Okay. And similarly, your battery capacity also increased. Usually, initially it was few hundreds of milliamps per hour. Now it has been increased to 10,000, 15,000. If you look at the battery research for over the years, if you look at here, the capacity of the battery has increased enormously. This again, the efforts of the research done by the scientists across the globe. Okay. Now coming to our topic, this is just a basic motivation why people want to do research. What are the extra? What is the impact on the society? Okay. Now we'll come to our part where we are going to see 2 parts. The first part is what is a nanomaterial? What is the basic is nanomaterial? And then we'll see different characterizations used for the nanomaterials. Okay. So let's start the topic. So this must have discussed by many people in the last 4 days. So I'll start little late. Like you see, people must have started from 1959. But actually, there was a monolayer films which was initially done by Langmuir in 1920 itself. Okay, but that was not recognized well. But the moment this lecture has come into picture, where Feynman has given a ideas. See, the nanotechnology is not invented; it is the initially idea. When you reduce the things, what happens? What kind of improvement you are going to get? That was the idea given by Feynman, and later it was developed, implemented, and we could able to enjoy the benefits of nanomaterials nowadays. We have antibacterial paints, antibacterial coatings, okay, and antibacterial solution for the injuries. So there are many places where your nanomaterials already produce the products for the human benefit. But this is the idea initially given by the Feynman in 1959. Now, this is a typical definition one can give for usual nanomaterial. If you consider any material in bulk form, your all the dimension will be in micrometer scale, like few centimeters to few millimeters. If you start reducing one of the size or one of the dimension to a nanometer scale, let's say 100 nanometer, we call them as a nanowires, sometimes nano particles or quantum dots, or 2D films. Okay, so under this category you get nanoparticles. This comes under zero-dimensional materials, and these are nanowires and nanorod. This comes under one-dimensional material, and other one is the films, which comes under two-dimensional material. So the dimension comes related to the how many dimension the movement of the electrons has a restriction. If you take the nanoparticle, the restriction is from all the three sides. Electron is completely located at one place, whereas in case of nanowire and nanorod, electron can travel along one direction comfortably. So that we call it as the one-dimensional nanomaterial. Okay. And this is how we can classify your zero dimension as nanoparticles, and one dimension as wires, rods, tubes, everything, and two dimensional as thin films or some coatings on any surface. And our research group also works on different nanomaterials like nanowires of silicon, germanium, indium oxide, tin oxide, and so on. And coming to the synthesis part, so these are the different synthesis methods one can prepare the nanomaterials. You have a physical method, you have a chemical methods, you have a biological methods. Okay, I'm not going into the details, but you can take it as an overview that these are the methods by which you can prepare the either one-dimensional nanomaterials or two-dimensional or maybe zero-dimensional materials. Okay. Now your basics are fine, like you know what is nanomaterial and what are the different techniques available for the nanomaterials. Now we'll try to see what are the different characterization methods which will be available for the nanomaterials. So before that, why do you want to characterize? What is the requirement for the characterization? If you look at here, the first picture is nanorods, second nanowires, second picture is nanorods, third one is nanoparticles, and fourth one is a graphene nanosheets, and fifth one is a carbon nanotubes. Okay, so before you put your sample into the microscope, you don't know what is inside the sample. It can be a nanowires, it can be a wires, it can be rods, or it can be a sheets also. We don't know. But when you want to use for a certain application, suppose you want to make a transistor, or you want to use in a drug delivery, or you want to use in a battery or capacitor, maybe battery storage element, you need to know what is the morphology, what is that particular nanomaterial that sample is having. Suppose if you want to fabricate a transistor of a few nanometer size, probably you may need to use nanorods or nanowires, but not the nanoparticles. So for transistor application, you should know the sample should have a nanowires. Then we can take one nanowire and we can make the device. For if you take a drug delivery, nanowires may not be a suitable choice. Your nanoparticles are the best choice. Similarly, if you want to make an energy storage device like supercapacitors or battery, your nanoparticles may not be a suitable option. Maybe a 2D material like graphene nanosheets or carbon nanotubes may be a better option for us to make a better device. So if you want to use any nanomaterial for any application, you should know what is the nanomaterial in the film, whether it's a one-dimensional material or two-dimensional material or zero-dimensional material. So that is the need for the characterization. Okay, hope I'm clear with what is the need for the characterization. Now proceed one by one. What are the characterizations are there to characterize our nanomaterials? Let's start with the simplest one. You must be wondering how camera can characterize a nanomaterial, how mobile phone can characterize a nanomaterial. See, sometimes we may not require to see the nanomaterial. Sometimes we can get the information from the observation of your sample. Once you prepare the sample surface itself will give an indication that there exists a nanomaterial inside. That whether the nanomaterials are formed or not also can be observed from the mobile phone images or maybe camera images. So I'll show you some examples how we can conclude that the sample is having some nanostructures. So let's take this property here, anti-reflection property of the coating. So if you take this first rightmost picture, there are two silicon substrates here. The first one is coated with some nano wire film of silica, and other one is not coated. If you look at here clearly, the second one is giving a higher reflection and first one is not giving any reflection. So it indicates that there is a film coated on it. There's the first thing. And your reflection of your film will tell you that there are some nanostructures inside. If you have a nanostructures, then probability for the reflection, like the reflection reduction will be very high for the nanomaterial film rather than the thin film. If it is a thin film form, again there will be a reflectivity. But whereas if you have a nanomaterials, if the light enter into these nanomaterials, or suppose if you take a nanowires are present on the silicon substrate, your light enter into these nanowires and it will trap inside. You don't get any reflection out from the substrate. So from the observation of your surface, you can conclude that there are nanomaterials, there is some nanomaterial present on the sample. So this is a visual observation one can get by looking at the picture or by taking the picture with a mobile phone. Similarly, with reference to different structures, you may get a different color. Okay. So that is also another advantage we get by looking at the surface or by taking a picture with the mobile phone. And second thing is, if you look at here, this is a super hydrophobic coating on a silicon substrate, a glass substrate. So once you fabricate the nanomaterial, if you want to check whether the nanomaterial is formed or not, what you can do is you can put a small drop of water with a fine needle, a fine syringe needle. And if the liquid droplet shape is in spherical shape, like what you can see in these pictures, like these pictures which I'm showing now. So all these pictures, your water droplet in spherical shape, this gives an indication that your surface is having a nanostructures. That's why your water droplets are staying without wetting the surface. Because when you have a nanostructures, the gap, the air trapped between the nanowires will push your water droplet upside. So as a result, the water droplet will not wet the surface. It will just touch the surface and leave it as it is. But whereas if you look at this glass slide where I'm showing my pointer, this glass doesn't have any nanostructures. As a result, it is just wetting the surface. But whereas in other pictures, you can clearly see a spherical morphology of spherical shape of your droplets, which has some nanowire coating or nanostructures are synthesized on the substrates. So by looking at the droplet shape, one can say that your nanostructures are formed on the substrate or not. Is that fine? Is that fine, everyone? Can someone confirm?
Hello.
Yeah, is it
Sir.
fine? Everything is going well, right?
You can carry on, sir.
Yeah, fine. Thank you. So similarly, you can also use your photographs for nanomaterials. When you prepare the nanomaterials, so your nanomaterial sometimes exhibits specific properties like electrochromic devices or electroluminescence devices. So when you apply the potential, the nanomaterials will get a color change because of some oxidation and redox reaction. So this is specially observable by taking a photograph. So if you take the photograph, you can see the color change of your materials very clear. Like you can see here in colored state and bleached state, how the color is being changed from transparent state to a violet color state here. And similarly, you can also tell you by looking at the pictures of your synthesis procedure of the product after you obtain your product. The color of the product sometimes may tell you whether nanoparticles are particles of which size is synthesized and all. So if you look at here, this is a special case where your nanomaterials will have photocatalytic degradation. So this activity mostly useful in decoloration of your dyes. So if you look at the pictures here, your optical photographs are very much useful in characterizing this particular activity, where you can see a color change very clearly. So similarly, your nanoparticles. So if you have a different nanoparticles of different solutions, each nanoparticle solution will have a different color because of your size. The size is different. There will be a different band gap. When there is a different band gap, they emit different colors to the outside, or they exhibit different colors based on their size. So by looking at the color, you can clearly say that there may be a particles of maybe approximate so much and so much size and all. So this is a visual indication by which one can conclude, only we can conclude that there are nanomaterial, there are nanostructures which are available on the surface or which are available in the solution. Similarly, you can also have transparent conducting oxide with ITO nanowires, where you can also see transparent state and bleached state, maybe transparent state and opaque state of your glass plate, which is coated with a nanomaterial. So same with electrochromic devices, you can take the pictures and you can conclude from that there is a change in the coloration by applying the voltage. Now this is a very simple one. This photograph is the simplest one. One can think of characterizing the confirmation of your nanomaterial is present on the surface or not. Now go to the second case, optical microscope. So by using optical microscope also one can characterize the nanomaterial some extent. So if you look at here, this is a confocal microscope, or you can consider the normal microscope here. So in this microscope, what we are observing in these pictures is we are exciting these nanowires which are placed on a substrate. When you excite these nanowires with particular wavelength of laser light, it is emitting other light in the form of laser. The people who studied laser must have understood that you have to give a excitation energy for the material so that it will generate the laser beam. So if you look at here, this nanowire at the end points, at the exit point, the intensity of the light is very high because the laser is coming out of the nanowire. So if you want to observe this one, the emission of nanowire or lasing action from a nanowire, one should use a confocal microscope or maybe a normal optical microscope, which has a better resolution. And you can take a photograph of the lasing action by the nanowire, a single nanowire, which will emit the laser beam. That will be useful to study optical fibers, like if you want to use in a communication purpose. You can use these nanowire based lasers for those particular applications. And similarly, you can also send nanoparticles which carry drugs into the human body, or maybe in this case it's mice. So after putting the drug into the body, you need to know where the drug is there. So you can put it under a fluorescence microscope or maybe optical microscope. You can illuminate with the UV light. So your nanoparticles will emit a kind of a luminescence that can be captured by using the optical microscope. So that means your nanoparticles are giving a kind of indication that where the drug is received, like where the drug is located after inserting into the body. Now comes here, this is the most useful one. This electron microscope, whatever we studied is a very indirect methods where we really don't see what is inside the sample, but we can only conclude that there is some nanomaterial. It can be wires, or it can be rods, or it can be particles. Now we are going to see exactly whether it is really nanoparticles or nanowires or nanorods. You have two kind of microscopes. One is a transmission electron microscope, other one is a scanning electron microscope. We'll see one after the other. In scanning electron microscope, we can get topography, morphology, as well as composition. So topography, morphology will give you what kind of surface it is. It is a nanoparticle surface or nanowire surface or maybe thin film surface. And composition will tell you what is the composition of your nanomaterial, whether it is having only one element or two elements. Okay, we'll see some pictures and we'll try to see. So what we do is in SEM, we'll put the sample inside the microscope, inside the chamber, and we'll try to send an electron beam. Your electron beam will interact with your sample. When it interacts with the sample, it will generate the secondary electrons. Those secondary electrons will produce the image for us. If you look at here, this scan generator, this will scan the picture, something like this, and you get the secondary electron. Those electrons will generate the image, what is on the sample. So this is the first one. If you put it under microscope, you can see here, this is a nail. You can see the clear features of nail, how it is looking, and this is a simple IC, and how the connections are given. And this is at a smaller magnification. If you go here, this is a higher magnification SEM images, where you can see the nanowires. So from this image, what we can say is, in this case, your nanowires are vertically oriented. In other case, your nanowires are aligned at particular angle with respect to the substrate. Whereas in this case, it is having a random orientation. Some are left side, some are right side, some are along the particular direction. So from this image, we can say that the sample is having nanowires, which are vertically oriented or randomly oriented with a particular angle. So based on the angle, we can say that nanowires are growing along this particular direction, maybe 110 or 101. Okay, so we get this basic information that sample is having nanowires or nanorods. Then you can know about their orientation and then alignment. Okay, this is the first information one will get from the SEM if you put under the electron microscope. And second thing is you can also get the length of the wires. So if you look at the last corner picture, you can measure the length of the wires, whether it's a 4 micrometer length or 3 micrometer length. And you can also measure areal density in a 1 micrometer area. How many nanowires are present? What is the areal density of that particular substrate, whether the nanowires are uniformly grown across the substrate or not. So all those information one can get from the microscope if you take a SEM images at a slightly higher magnification. If you look at here, so this is at 25,000 magnification B picture, whereas if you look at the C picture, it is at 50,000 magnification, and your A picture also at the 50,000 magnification. Okay, so this is how we can get information about what is the surface which is having, whether it's a nanowires or nanorods. If it is a nanowires, we should know all the information about length, diameter, areal density, alignment, and all. If you look at here, this is a nanotube structure which are formed in the sample. In this case also, we can measure the diameter of the tubes. We can also measure the length of the tubes, how long this mat has been grown, this nanotube mat has been grown. Okay, and what is the alignment, whether they are aligned vertically or they are aligned or they are lying on the substrate directly. So if it is a nanoparticle surface, suppose your prepared sample is having nanoparticles, then we can measure the shape of the nanoparticle, whether it is spherical in shape or cubical in shape or hexagonal in shape. And after that, we can use the ImageJ software. So by using this software, you can calculate the average size of your nanoparticles. From the SEM image, you take the SEM image, you import this image to the ImageJ software, and you can map the image, then you can get the particle size of your, or average particle size of your sample. So this is one information you get it from the SEM image, like what is the shape of your nanoparticles, what is the distribution of your nanoparticle, and also you can also individually measure the size of your nanoparticles directly by using the SEM. If it is a thin films, so your 1 dimension is over and 2 dimension, 0 dimension is over. If it is a thin films, you can measure the thickness of the films which is coated on the substrate. Suppose if you have a multi-layer film, you need to know whether you really coated exactly same thickness or not. So you can measure it using the microscope. So if you look at this picture where I'm putting my pointer, where there are 4 materials which are coated at different thicknesses. Okay, so this can be verified post experiment. Suppose while coating, you must have coated for 150 nanometer. You can cross check with the microscope whether it is 150 nanometers or not. Similarly, we can also measure the thickness of the 2D materials. Like if you have a graphene nanosheets or MXene sheets, you can find out what is the thickness of the sheets or what is the width of the sheets by using the microscope. And similarly, we can also know about the different morphology of variety of material. Like zinc oxide can form variety of materials. Some are flowers, some are tetrapods, some are tree-like structures. Okay, so all those information you get from the SEM image. This is only imaging part, which will tell you that what is the material, what is the dimension of the material, what is the density of the material, what is the alignment of the material. Okay, so now we'll go to the second mode. In the SEM, we have a backscattered electron mode where we collect the backscattered electrons. By using these backscattered electrons, we can find out the contrast in the elements. Suppose if the material having 2 elements, when you take the SEM image with the backscattered electrons, you can get the contrast. If you look at in this case, the first picture, you can see small white dots there. Those all white dots are having a different element, and other part of the wire is having a other element. Similarly, in this picture also, you can see there are white region, there is a black region. So this gives you information that there are 2 elements in the sample. Or if you take the third image, there are various phases. This material having a multi-phase material, so each phase will have a different color contrast. So here also you can see the tip is different in color and wire is in different color because of these 2 are 2 different elements. So we can only conclude here that these 2 materials are different. That information we know, but we don't know what is the other element. X-ray detector here. So this X-ray detector will detect the X-rays coming out of your sample and will produce a map here. So if you take this example here, there is a nanowire and there is a tip in the white color here. If I take EDAX on the tip, I'm going to see gold is the major content, whereas if I take on the stem, I'm going to see indium and silicon, indium and tin is a major element. So it can conclude that this nanowire is made up of indium and tin, whereas tip is made up of gold. Similarly, you can take this wires here. You can also do the mapping. So elemental mapping means you are going to scan the entire surface and collect the X-ray intensity, and you can map it with respect to your element. What is this particular element and what is this particular element? And the advantage is you can get the 3D image in the SEM. We can use almost films, powders, everything. Only disadvantage, we cannot get a information below 10 nanometer scale. You may not see the clear image of atomic arrangement, or you may not clearly distinguish the if two particles are attached to each other. Okay, so this is the first limitation. Second thing is we cannot use the liquid samples. We can only use the solid samples. So this is the SEM where it gives you a information about the material size, dimension, alignment, and composition. Now the resolution of SEM can be overcome by using the TEM machine, where we are going to use a high voltage of 300 kilovolts. With this high voltage, your electron wavelength will be reduced to a smaller size. Then we can get information which is order of few nanometers to few picometers also. So as I said, an SEM is giving the topography, morphology, and composition. Now I'm going to tell you the crystallography information is missing. We did not get any crystallography information, whether your nanometal is crystalline, whether your nanometal is amorphous. So to do that, and also we did not get any individual nanomaterial information. Not only the information, we did not get any individual thing. It is getting combination of all the nanowires or combination of all the nanoparticles in the SEM. So to get the crystallographic information, we have to use the X-ray diffraction method. So it's as usual powder XRD or thin film XRD, or sometimes we have to use the small angle X-ray machine to measure the crystalline property of the materials. So in general, for a single crystal, you will be getting only one peak depending on the orientation of the planes. So in this case, only one peak, it is 110. Whereas in this case, it is only 111, which is coming here. This is single crystalline material. If the polycrystalline material, your planes are arranged in a different direction in each domain. So you get a multiple peaks from each domain. So you get the different peaks. Whereas the amorphous, you don't have any diffraction peaks. So this is a simple classification of single crystalline material, polycrystalline material, amorphous material. So whereas in nanomaterial case, this is for a generalized one. So whereas in nanomaterials case, how do you confirm whether your sample is having a nanomaterial or not? So when you take X-ray diffraction of your nanomaterial, your X-ray diffraction peaks, it get broadened with the size. If you look at the last picture here, the bulk one has a sharp, intense diffraction peaks, whereas your nanoparticles of smaller size are getting broader peaks. Same thing with here, bulk silicon is having a very sharp peaks, whereas silicon nanoparticle having a broader peak. So from this observation, we can say that your sample is having a nanomaterial first thing, and you can say that all these nanoparticles are crystalline in nature, but we don't know whether they are all are single crystalline or not, because the orientation of nanoparticles are random. So to find out the size, what we can use the origin software or expert high score. So you have to find out the full width top maximum of this peak and find out the crystalline size by using the Debye-Scherrer formula directly. So in a way, your X-ray diffraction will give you whether the nanomaterial, the nanowires or nanoparticles or film is crystalline or not. If it is a crystalline, polycrystalline or single crystalline. If it is a nanoparticles, it will tell you what is the average size of your nanoparticles. So suppose if you take the proteins, DNA and RNA, in those, even though they are in the nanometer scale, we cannot use XRD for that. We have to use a small angle X-ray scattering machine. So in which we are going to get information about the proteins, DNA and RNA, and also if the nanoparticles are immersed in the solution, we also get information about the nanoparticles. So what we do is we prepare the sample in the liquid form and we send X-ray source to the solution, and the scattered X-ray intensity will be mapped. That mapping will give you indication of size and shape of your material. If you look at here, the small dot is having a different pattern and bigger dot will having a different pattern, and square shaped particle will have a different pattern. And if you take group of particles, each combination will have a different pattern. So by this pattern, we can tell the size and distribution of your nanoparticles. So if you look at here, your nanowires will have a different graph, and your spherical nanoparticle has a different graph, and your core shell nanoparticle will have a different graph. So from this, we can analyze the nanoparticle size and shape. Of course, protein structure also can be analyzed by using the SAX machine. Now listen carefully, whatever we measured till now with the SEM or XRD or SAX, everything is a bulk. We did not do any measurement on single nanowire or single nanoparticle or single nanosheet. So with use of TEM machine, we can do measurement on single nanowire or single nanoparticle. So we'll see some images here. So in transmission electron microscope, what we do is we pass sample, like we pass your electron beam through the sample. That means your electron beam will pass through the sample and produce an image at the bottom. This image will give you information about your sample now. So previously in SEM, we collected the backscattered electrons and secondary electrons. Now we are going to collect the transmitted electrons and diffracted electrons to get the information about the nanomaterial sample. So this is a TM sample preparation, how you prepare the sample. You scratch the sample surface and make the powder slightly. That powder will be dispersed in a small solution, maybe acetone or methanol, and you put it on a carbon grid, and the carbon grid will be loaded into the TM machine. And you can see here all are individual nanowires now. Even though you're getting group of wires here, you can isolate to one picture here. You can get individual nanowire image, what is the size of the individual nanowire. And you can also get the elemental contrast if they are having more than one element. You can also get whether it is a single wall carbon tube or multi-wall carbon nanotube by using the TM machine, which is not possible with the SEM machine. And you can also get the accurate shape of your nanoparticles, accurate thickness of your sheets. With the core shell particles, you will also get a clear image of core material as well as the shell material. And you can also get the atomic contrast, like you can also get how your nanowires has been grown, which direction it has grown. Whether the single nanowire is crystalline or not also can be get by taking the selected area diffraction on this wire. You get the diffraction spots, and you can conclude that this wire is single crystalline in nature. You can also clearly see the atomic arrangement by using the HRTM. By using the HRTM mode, you can get the atomic arrangement, how atoms are arranged inside a nanoparticle or maybe a thin film. And if you take the selected area diffraction on the sheet, you can get the diffraction spot, which clearly confirms the given single wire or given single particle is crystalline in nature. And you can also get the composition of the individual nanowire. So if you look at here, this nanowire will have a tip and a stem. The stem is a different composition and your tip is a different composition. This can be clearly done. That means you can individually confirm whether this particular nanowire is having two elements or not. Similarly, we can also do the elemental mapping to make a more clear image of how your nanowire composition is distributed along the length of the wire. As I said, crystallinity will be given. If there are dots in the selected area diffraction, we can say it's a single crystalline nature. If there are circular rings, and then we can say that particular nanowire is amorphous in nature. And you can also find the defects inside the graphene sheets or maybe amexine sheets by taking a high resolution image of your atomic arrangement. We can use digital microgram software to make to get the information or to get the image manipulation by using this particular software. So with the transmission electron microscope, we can get the morphology, we can get the composition of the individual nanowires, you can get the crystallinity, you can also get the defects. So we are going to get almost all the information from the transmission electron microscopy for a single wire or single particle or maybe a small graphene sheet or whatever it is. Okay. Nowadays, this is a recent technique. Now people are doing in situ TEM, where we can apply the temperature while taking the imaging, or you can apply the electric field, or you can apply the liquid or gas environment. We can even observe the nanowire growth inside the TEM. While nanowire is growing, we can take a video of that. I'll show you now. So you can see these videos are recorded while measuring the while growing the nanowires. So you can see the second one where the nanowire is growing here. This is a in situ recording.
Electron microscope video, silicon nanowires growing in gold particles.
And
Nanowire is
the below one is the nanoparticles growing inside the transmission electron microscope.
Hello, Rakesh sir.
So these images are recorded
Am
while
I audible, sir?
nanowire is growing inside the transmission electron microscope. So this is a one
Am I
where
audible?
people are observing the
This is
real-time
reference
growth of
to the
nanowires or
VNRVJIET.
nanoparticles.
real time.
Sir, your voice is not audible, sir.
Can you hear me now?
Hello, sir.
Can you hear me now?
Rakesh sir.
Hello? Hello? Can you hear
Hello,
me?
Rakesh sir. Am I audible to you?
Can you hear me now? Hello? Can you hear me now?
Rakesh sir.
Can you hear me? Hello? Can you hear me now? Can you hear me now? Can you hear me now? Can you hear me now?
Hello, Rakesh sir.
Hello? Can you hear me
You are
now?
not audible, sir.
One second, sir. Shavanti.
Excuse me, sir. Rakesh sir.
Hello? Hello?
Hello, sir.
Are you here?
Your voice is breaking, sir.
Hello?
You are not audible properly.
వినిపియలే? ఒక్క
Yes,
నిమిషం.
sir.
Right.
Your audio is not clear, sir.
1 second, sir. Let me check. Can you hear me now? Hello, can you hear me now?
Yeah, yes, sir.
Yeah, I'll just
Yeah,
finish
yeah, sir.
5 minutes time.
You
Okay.
carry on, sir.
Yeah, I'll finish in 5 minutes. I hope you can see my screen, right? Can someone confirm? Can you see my screen?
Yeah, sir. Share our screens.
Yeah, fine.
Yes, sir.
Yeah, fine. I'm just finishing 5 minutes. Yeah. So you can use in situ TM while growing the nanowires and nanoparticles, how they grow with respect to time. And this another image where you can see clearly layer by layer forming. And further, we can use zeta potential to measure the particle size measurement of nanoparticles. And finally, we came to a last part, there's the STM and AFM. So these two are the versatile techniques which can be used to get the atomic resolution images where you can image individual atoms. So where in one case, you're going to use a tip which will scan over the surface of a material. Another case, it will be based on the force. Both the methods by the STM or AFM, both are going to give a atomic resolution images where your atoms are arranged in a particular fashion, where you can see the atomic arrangement of individual images. And we can also use the software for analysis of your AFM. And finally, we can also use Raman spectroscopy to characterize an nanomaterial. Like you can have, suppose you have a multi-layer or single-layer graphene films or single-wall, multi-wall carbon nanotube films. We can get a different spectra for single-wall carbon nanotube and multi-wall carbon nanotube. By looking at the Raman spectra, one can say it's a single-wall or multi-wall carbon nanotube. So I just conclude here. So special thanks to Tirmal Reddy and Srinivas Rao for inviting me to this workshop. So time was little less, so we could able to make it this much. So I thank all the audience for your patient listening, and thank you all.
Thank you very much, sir, for your inspiring speech and talk on advanced characterization of nanomaterials, especially in terms of XRD, TEM, Raman spectroscopy. You have emphasized the fabrication of zero-dimensional, one-dimensional, two-dimensional, and three-dimensional nanomaterials. And also you explained the device fabrication, especially used for electrochromic materials and lasers. You discussed the topic on biosynthesis of samples also, suggested two softwares for young engineers and researchers, image software and origin software. Now the presentation is for discussion. Students, we welcome you to ask any queries. Yes, students, if you have any queries on the talk, please welcome. Yeah, sir, I think there are no queries. So thank you very much, sir,
Yeah,
for
thank
your
you all.
wonderful
Thank you
talk.
also. Yeah,
Once again, we thank you very much, sir. Please give him a big round of clap. Thank you, sir.
thank you, sir.
Good evening, one and all. It is an honor and privilege to welcome you all to the valedictory ceremony of IEEE Nanotechnology Summer School, a 4-day training on fabrication and characterization of nanomaterials organized by the IEEE Hyderabad section in association with IEEE VNRVJIET student branch and NTC student chapter. To improve the golden movement of opportunity and catch the good that is in our reach is the great art of life. The 4-day training program on fabrication and characterization of nanomaterials with the theme designing nanomaterials with multiple functionalities from understanding the different fabrication methods and characterization techniques focused on different methods related to fabrication of nanomaterials and thin films, provided a platform to the participants with a flavor of the recent advancements and ongoing research in each of these areas, provided an opportunity to understand the fundamental principles of fabrication of nanomaterials, which is essential for every engineer who deals directly or indirectly with materials. Over the last 4 days, we have had deep insights into on basic characterization techniques related to structural, thermal, optical, microscopic, microwave, and nanomechanical properties of materials. Now, the time has come to draw a curtain to our program as we come to the close of it. We welcome you all to the valedictory ceremony of a remarkable, memorable, and knowledgeable 4-day training on fabrication and characterization of nanomaterials. We promise you that this may be the end of today's session, but surely this is going to be a new beginning. The last 4 days focused on the latest research fields and applications in nanotechnology, basic fabrication of nanomaterials. May I take the privilege of inviting the dignitaries onto the dais. Please join me in welcoming Dr. C. Tirmal Garu, Program Chair, to grace the dais. Thank you, sir. May I take the privilege in inviting Dr. V. Priyanka Garu, Finance Chair, NTC and Branch Counselor, IEEE VNRVJIET, to grace the dais. Thank you, ma'am. I take the privilege in inviting Dr. Y. Padmasai Garu, General Chair, NTC, and Faculty IEEE VNRVJIET to grace the dais. Thank you, ma'am. May I invite Dr. T. Jayashree Garu, Head of the Department, Humanities and Sciences, to grace the dais. Thank you, ma'am. May I invite Dr. D. Chanakesava Rao Garu, Director, VNRVJIET, to grace the dais. Thank you, sir. Thank you all for joining us. May I request Dr. C. Thirumal Garu, Program Chair, to address the gathering.
Very good evening, dignitaries on the dais. And I'm very happy to say that from last 4 days, we have completed a very good training on fabrication and calibration of nanomaterials. We have given 6 distinguished lectures, 11 independent talks on different nanotechnology fabrication methods as well as characterization methods. Along with that, we also try to explore the importance of nanomaterials in the various fields like medicine, engineering, and science. We have actually given an overview of the importance of nanotechnology through the various applications, starting from memory device to nanomedicines. We hope the participants of this particular program have got enough knowledge to start in the field of nanotechnology. With these few words, I would like to thank our management, our HOD, our lead progression, and especially the IEEE NTC chapter Hyderabad chair, Dr. S. Subramanian sir, is also online with us. So thank you one and all for joining with us today.
Thank you, sir. We would also like to welcome Dr. Santosh Sivasubramani Garu, Founder Chair, NTC, for joining us virtually. May I request Dr. B. Priyanka Garu, Finance Chair, NTC, and Branch Councillor, IEEE VNRVJIET, to address the gathering.
Good afternoon, all. I hope you all had a very great session from the last 4 days, and we have gained some sort of knowledge depending on the expertise of the nanotechnology. The student branch of VNRVJIET conducts such type of activities regularly, and we make sure that our students will be having the updation of the knowledge. We student branch has total 5 chapters and 2 councils and 1 affinity group. And so we will be conducting various number of activities in collaboration with the surrounding engineering colleges as well as the Hyderabad section also. So every time we will be make sure that our students are getting the knowledge which is right now, it is updated. Okay. So regarding this event, what has been conducted regarding the seasonal school, I would like to call upon my student chair, Aditya, of nanotechnology, to give you a brief report about these 4 days.
Good afternoon all. I'm Aditya, Student Chair of NTC VNRVJIET. I would like to give a brief report on our 4-day IEEE NTC summer school. Starting on day 1, we had the inauguration ceremony at KS Auditorium with the objective of designing nanomaterials with multiple functionalities. From understanding different fabrication methods and characterization techniques, graced by our guest, Dr. C. Thirumal Garu, Program Chair, Dr. Y. Padmasai Garu, General Chair, our Principal C. D. Naidu Garu, Director B. Chanakesava Rao Garu, Dr. S. Santosh Kumar, Founding Chair, IEEE NTC Hyderabad Section, and J. Suryanarayana Garu, Associate Professor of IIT Hyderabad, with 16 distinguished speakers and 11 invited talks. So here are few other speakers. Dr. J. Suranayana Garu, Associate Professor of Department of Physics, IIT Hyderabad, who lectured on present and future non-volatile memory devices. Dr. S. Santosh Garu, SM IEEE, Founding Chair, IEEE NTC Council, lectured on simulation and experimental investigation on nanomagnetic project towards reporting. Dr. C. Thirmal Garu, Assistant Professor, Department of H&S, VNRVJIET. Day 2 kicked off with Professor Landfu, and a few lectures and talks by faculty of VNRVJIET. Day 3 started with Dr. B. Sujay Kumar, Inspire faculty, IISc, adding two more talks by the invited speakers. Lastly, on the final day, day 4, with few more speakers and ending session by distinguished speaker Dr. R. Rakesh Kumar, Department of Physics, NIT Warangal. I thank all the participants, faculty, and support of all the speakers, staff, principal sir, and director and deans. Thank you.
Thank you, Aditya. May I now request Dr. Y. Padmasai Garu, General Chair, NTC and Faculty, IEEE VNRVJIET, to address the gathering.
Good evening to one and all. Respected dignitaries present on dais and off the dais, and my dear students. Even though it is very difficult to follow by listening to eminent speakers, all recordings are available in our VNRVJIET website. Okay, please go whenever you are finding some time. Please go through that. If you are having any doubt, we are having all our physics faculty is having expertise in nanomaterials and nanotechnology. We are having lab 2 in our college. Still, if you want any facilities, IIT Hyderabad is supporting us. We can use those lab facilities. Even if you want further, IISc Bangalore as well as IIT Delhi also we are having connections. Okay, you are having sky is the limit to grow. I request all the students. So even though some of the students they mentioned some of the points we are unable to follow, but I know. So why? Because why we asked you to attend this program? Young brains will think differently. So different thinking comes under innovation. Routine thinking only routine works will carry forward, but you're having young brain, think differently, and we want to see by the time you are coming to third year, many of you are able to provide job to many students. So instead of looking for job, we should be able to provide job. Okay, I thank all the students and the participants joining this event. And I also thank all my colleagues and principals sir, directors sir, and all faculty members of Physics Department of H&S of our college. They have nicely coordinated with us, and because of that one, we are able to conduct this program successfully for all these 4 days. And I also thank Dr. Atul Negi sir, interim chair, IEEE Hyderabad section, and also Dr. Santosh, founding chair, NTC IEEE Hyderabad section, and also general chair of this NTC event. I thank one and all for making this event memorable. Thank you, one and all.
Thank you, ma'am. May I request Dr. T. Jayashree Garu, Head, Department of Humanities and Sciences, to address the gathering.
Okay, good afternoon, respected dignitaries and dear students. I think this has been a nice exposure for you all. It may be the first time. It's a change from the regular classes that you've been attending. And even an iota of information that you have picked up from here could probably help you to advance in that subject if you've got some interest created there. And I'm sure that this is the first of its kind for you, especially having joined just recently.
and a brief about what is the objective. I think you all know that this field is something which is very new, nanomaterials, and especially when you're going to delivering some sustainable products, it's important to have the nanomaterials in mind. So this is a platform to encourage you to try and see what you can do best, especially after the first year, during the first year, as you go through the 4 years. And as ma'am said, be a little innovative and try to come out with some societal impact ideas. I think that is my message. I thank all of the team of NBC, especially the physics faculty who've been doing a great job, and all those behind the scenes also who helped to make this a great success. Thank you so much. Thank you, ma'am. May I now request Dr. B. Chanakesava Rao Garu, Director VNRVJIET, to address the gathering.
Good afternoon to all of you. Good afternoon.
Good afternoon, sir.
So first, let me congratulate Padmasai Madam and Dr. Thirumal and Jayasri Madam and Priyanka Madam and all other student volunteers and Santosh. I think he's there on the line, online, and dear faculty members, Elsie Nivas, Ashok, and all other faculty of physics, chemistry, maintenance department. My dear students, ladies and gentlemen, at the outset, I would like to thank all the delegates. I think without your support, without your cooperation, it is not possible to conduct any event successfully. So please all of you give began to all the delegates that are attending this conference, this workshop. And at the same time, I think resource persons are also equally important. I think without their support, also it is not possible to conduct any event successfully. So in this connection, I would like to thank all the experts who have come forward to deliver the lectures during this 4 days workshop on fabrication and the characterization of nanomaterials. I think already some of the speakers, they are told that this is the beginning of your research in this particular area, because attending this type of workshops, I think is a routine duties. If you want to learn new things, I think you have to attend this type of workshops and acquire new knowledge. That is very important. Once if you can learn basics, so definitely you can build whatever the way you want actually. So like a material, already in the first day itself, I told you that once if you can select the best material which is suitable for a particular product, I think 60% of your job is over. And the remaining 40% only, how we are going to optimize the various parameters, how we are going to reduce the cost, how we are going to improve the applications point of view. So these are some of the things I think each one of you have to learn. So in this connection, I request all of you, please try to explore, because whatever the information that the experts I think they gave in this particular 4 days, so that may not be sufficient actually. So unless you explore some more knowledge in this particular area and try to publish papers, okay, because this is upcoming area, nanotechnology is one of the most sought after I think area. So each one of you, I think, please try to, those who want to pursue your research, so I think this is the right platform. So please try to pursue and publish, and that way I think you can improve your knowledge. That's one thing. And the second one is the networking. So that is also equally important. So unless you interact with experts, unless you can, so suppose you're not going to interact with the, especially outside college people also, because what we are thinking that we are doing extremely good in this particular area, but when you're going to discuss with outside experts, definitely there is a gap. So that gap, I think you can fulfill, provided if you have a good network. Okay. So this type of platform definitely will help you to improve the networking with other scientists, those who are doing good job in this particular area. Okay. I once again thank you all of you for sparing your valuable time. I wish you all good luck. Keep up. I think whenever we're conducting this type of event, please try to attend and grab the opportunities. I wish you all good luck. Thank you.
Thank you, sir. May I request Dr. Santosh Sivasubramani Garu, Founder Chair, NTC, to address the gathering. Hello, Santosh sir. Sir, are you able to hear us, sir?
Hello.
Yes, sir, we can hear you, sir.
Can you hear me now?
Yes, sir. Yes, sir.
Hello.
It's not very clear, sir.
Okay. So yeah, first of all, I would like to thank the management of VNRVJIET for providing the platform to get this IEEE Summer School on Nanotechnology hosted at their institute. I extend my sincerest thanks to Padma Sai Madam, who has been instrumental in shaping this up, and Dr. Thirmal Garu and all other deans, faculties, and management who are part of this. And thanks to Priyanka Madam, who are also taking care of all other activities, and all other colleagues and student volunteers of IEEE VNRVJIET. I would like to mention special thanks to IEEE Hyderabad section and the able EXICA members of IEEE Hyderabad section, IEEE Hyderabad section interim chair Dr. Atul Negi sir, and Dr. Jabbar and Dr. Jayaprakasham and Dr. Venkatesh for their support and their belief in part of doing the activities globally and as well as throughout the section. I also thank the IEEE NTC team led by the educational activities, Professor Lanfu and Professor Ding, and the past president James Morris and the current president Fabrizio Lombardi for their continuous support on giving funds for the IEEE activities towards educational activities. This summer school is part of the IEEE Educational Activities Program NTC, and their financial support is greatly valued, and it has been properly utilized, and the 4 days has been successfully completed, and I believe all of the students who attended this had a wonderful time and had great knowledge and networking which can happen, and it is a lifetime memory. So you can reach out to any of us, or you can reach out to your college staffs and principals or your course faculty advisors, or directly to me if you require any support help in Nanotechnology Council, and whatever it is we can extend it to do the needful. So IEEE NTC Hyderabad section is always available for all the activities. And here also I would like to reiterate that there is a radio show context which is ongoing as part of this IEEE second Hyderabad Nano Day celebrations. And I want active participation from the NRVJIT. So this is my humble request to all the student volunteers and the post faculty members of IEEE. So encourage them at least minimum 3 groups from VNRVJIT to participate in this radio show context, which is going to talk about a group of 3 or 5 people can talk about this quantum computing or neuromorphic computing as an audio podcast. So looking forward to host many other such events in the near future. And thank you for this opportunity. Thank you all.
Thank you, sir. I request anyone among the audience to share their experience. Okay, may I request our director, sir, Dr. B. Chenakesa Rao Garu, to present memento to our student coordinators. Aditya of 4th year ECE, Chair NTC. Rishik from 4th year EIE, Chair IEEE SB. Okay. Veda of 3rd year ECE, Vice Chair IEEE SB. Prashant of 3rd year ECE, Secretary IEEE NTC. Kirtana of third year EC, Vice Chair IEEE NTC. May I invite Kirtana, Vice Chair IEEE NTC, to propose the vote of thanks.
Gratitude is the fairest blossom which springs from the soul. Every celebration is an experience. The external fades away and the internal lingers and echoes in the most depth of our hearts. Respected principal, directors, distinguished members of management, faculty, students, our most valued guests, and grand finale participants, parents and friends who have joined us virtually. It is my honor and privilege to propose the vote of thanks to all of you present here. We would like to thank IEEE NTC, IEEE Hyderabad Section, Management of VNRVJIET, Principal VNRVJIET, Directors, Deans, Head of Departments for supporting us throughout the event. I extend my gratitude to members of faculty coordinators of various committees, student volunteers, faculty, staff, students, online streaming team lead by Srinivas Sir and Balaji Sir for their valuable guidance and immense support in making this event a grand success. I would also like to thank Dr. G. Radhakrishna Sir, Department of EC, for coordinating with the students. A special thanks to Team Nrityataram for making this event a lively one. I cannot thank everyone enough for the involvement they have shown. Last but not the least, on behalf of VNRVJIET, I extend a hearty vote of thanks to all of you. Thank you, everyone.
I request everyone to stand up for the national anthem.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जगधि तरंगा तब शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जन गण मंगल नायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे